I wanted to go into a little bit of a talk about brushless motor I'm about ready to have some experience with. These SCX 30s have been fantastic. This one on the left here is pretty much pure Endura and Furytech. Endura everything and Furytech electronics, besides the Enduro servo. It's a nice little unit. It's my first experience with brushless on this scale. Used a lot of brushless in the 1/10. Haven't put any in my 1/24ths. But here it is in my 130. I have a 130 with this brushless system. This was about the max of my rigs until this little bugger came into play and decided to be king of the hill. I haven't proven anything. I need to get him out in the rocks, but that's a good little rig. This one here was up there. I don't know what else I really needed to do to improve this one. The motor system would probably be all it really needs from here on out. I don't know. Probably run it like this until I burn that motor out and then decide. However, my experience with this so far tells me these little buggers, these brushless systems are just sweet. If the fine low speed stuff is what you're chasing, then that's how to do it. This guy is, let's see here. This guy is that CR18 55T high torque motor. It's a 55 turn as opposed to the stock ones. This 65T, 65 turn, and this 88 turn. They're the stocks that they put in these. Chuck with one and the Jeep with the other. Broncos, I think the same as the Jeep probably. If I guessed which one was which, I'd probably get it wrong. I forget. However, this is called a 55T. As you can see, it's much longer. So anyway, I bought a batch of these back when I was messing around with the 24s, just to have them on hand. I don't even know which one that is right there. I don't know. Whatever. And this guy is the Furytech system. The Furytech Nanomoto. It's got the ESC, it's got the brushless motor, it's got the transmitter and receiver, and it's built specifically for the SCX 30, it says. I mean, it works nicely in here. I don't know why it wouldn't work in a 24, but whatever. Not mine to do right now. It's a nice little system. It's a very nice little system. But let's see. Let me show you what the heck the big difference for me is. And this isn't bad. This little guy I've been messing with quite a bit. He ain't bad. Probably wants to be turned on again. Okay. Now, I want to pay attention that I'm not doing this. I'm trying to run this as smooth as I can. I'm going to go climb those tires and do it just as smoothly as I possibly can. You see, as soon as it touches, I can get it to go slow. And as soon as it touches, it stops, and I got to give it more power. So that's the voltage. I'm just adjusting the voltage. Right now, there's 0 voltage being applied to the motor. As I push the trigger, and it applies voltage. But I need enough voltage, equaling power, to do that little bit of extra work. If I do it again, just roll up on that as slow as I can. See, the slow is tough. There we go. As soon as I touch, it needs more volts to get over it. It makes sense, doesn't it? Volts is work. Applied voltage, amps is work. Okay, fine. But it needs volts to push the electricity. It needs pressure to push the electricity. Now, pay attention to this one. Do the exact same thing, but look at that motor. It's called an outrunner, but holy cannoli! The brushed motors don't turn that slow. Look how slow those tires are turning. Now, it's not just that they're turning slowly. Get up there. Oops, I'll back up a bit. It's not just that they're turning slowly, but watch when I reach the point of needing more voltage to get up those tires. Okay, got my trigger pushed, and now I'm not going to do anything else. I'm holding it right where I'm holding it. I'm not doing anything. I'm not moving. It just maintained that rotational speed. It just maintained that as I just barely held that trigger. This slow speed is just crazy. There's just no comparison. There's absolutely no comparison between that brushed motor and this brushless. My word. Well, it's got okay speed. I'm not looking for speed. Anyway, I just wanted to point that out. I think that's one of the important functions of these systems, is to get that kind of control at that low of speed where I can just hold the trigger in one position and the dang thing just maintains that speed, and in its own electronics, it's increasing the voltage. Yep, it takes more volts. It takes more pressure to get more work out of that little motor. So when I tell this one, give it a certain trigger position, the motor's going to turn at a certain speed, and it's going to maintain that. It may take a little bit more voltage. It may take less voltage, but it's going to maintain that speed of the motor. Versus this one, when it reaches resistance and it needs that voltage, it needs that voltage to be bumped up. It needs it. Then this supplies it. This supplies the needed voltage. They both do, but the trigger's direct, and that's why you see that pause when it hits a load, and I've got to give it more power to get past that. I've got to give it more power on the trigger to get over that hump. No big deal. I mean, we've been doing this forever, and I'm just saying I'm used to it. I'm not complaining about it. I'm not saying that that's a terrible thing. It's what you get used to. You're used to it. People are used to it. They know they hit a bump, and you got to give more trigger, and you got to get enough to get over the hump, and then oftentimes it's too much, and whatever. It's the way it works. It's the way they are. But with that system the way it is, I don't know. That's a whole new feeling And it feels pretty good. It climbs very nicely. Okay, I'm going to shut up about that now. I'm just very impressed with the brushless system, and I look forward to experiencing it.